Here we can see with all his evidence what Wegener hypothesized Pangaea probably looked like. We can see the folded mountains in South America and Africa lining up, and those bands of fossils that he saw, again, South America, Africa, India, Antarctica, and Australia. We make that band where those were probably connected. The big evidence in North America and Eurasia is going to be that line of coal beds, which again speaks to a once ancient forest being in that location, and those being much closer to the equator in a much warmer, more temperate environment than they're found in now. So this was his hypothesis. Let's talk about his eventual theory that was actually published. In 1915, Wegener actually published all of his evidence and all of his findings in one cohesive theory. The name of the book was The Origin of Continents and Oceans, and the name of the theory he came up with was Continental Drift Theory. What Continental Drift Theory actually states is that at one point the continents were connected and have since moved apart from each other. Now, you might think, oh, yay, scientists saw this, it was great, everybody said, wow, we've learned something new. But as usual, most new ideas are often met with skepticism, and that was definitely the case in Wegener's time, just as it is now. There are two primary reasons that scientists in Wegener's time did not accept his theory. Wegener attempted to explain how continental drift took place, which is always important in science. He suggested that maybe the continents were plowing across the ocean floors. Unfortunately, he couldn't provide an explanation that made sense for where this force was coming from. Obviously, continents are very large. How exactly are they moving across the oceans? Because Wegener couldn't identify the cause of continental drift, most geologists rejected his idea. There was, however, a second reason they also rejected his idea. Let's take a look at that. For geologists to accept continental drift, they would also have had to change their ideas about how mountains form. Wegener came up with an entirely new idea when he was looking at those mountains in South America and Africa. He decided that what had actually happened to form those mountains is at one point those two continents had run into each other, and those had pushed up the land into big mountains. And that's very new and totally contradicted what they thought at the time. In the early 1900s, many geologists thought that mountains formed because the Earth was slowly cooling and shrinking. And if you think about something drying out like an apple, the skin of the apple is going to go ahead and start to prickle up and get little wrinkles in it. And that was how they thought mountains formed at that time. We now know this isn't true, and in fact Wegener's idea about mountain formation was true, at least for some mountains. But again, whenever there's an already established idea in place, it takes a little while for people to back off and accept that new evidence to change their minds. So, if nobody accepted Wegener's idea, why are we talking about this? Wegener continued to work throughout his life attempting to prove his hypothesis and prove his theory was correct. And unfortunately, when he died in 1930, he was exploring a continental glacier trying to get more evidence. The scientific world at large still did not accept his theory. So why are we talking about it? Well, let's see what happens next. The good news is eventually Wegener was vindicated. Other geologists realized he was correct. We had to get some more evidence and add some new things in, and eventually what they discovered was how it was actually happening. How are these giant continents moving around our planet? And I know you want to find out right now, but we're going to go ahead and wait. That's going to be in our next couple sections in our book. I'm going to have you guys go ahead and watch a short video clip here that's just going to sum up, again, some of what we've already learned and let you know a little bit about Alfred Wegener.
Germany, 1911. A meteorologist named Alfred Wegener was browsing through some books when something caught his eye. A list of identical plant and animal fossils that had been found on opposite sides of the Atlantic Ocean. Wegener was intrigued. How could the same species have gotten from one part of the world to another? He examined the eastern coast of South America and the western coast of Africa and was struck how the shapes of the two coastlines might fit together. The more he looked, the more links he found. Species of land mammals in East Africa also inhabited the island of Madagascar. How did that happen? Did the animals evolve in both places at once? Or did they somehow cross from one land to the other, swimming hundreds of miles across the Indian Ocean? And then Wegener saw it all clearly. He realized that all the continents in the world had once formed a giant single landmass that he called Pangaea, from the Greek Pangaea, meaning all Earth. It was in Pangaea that the plants and animals found on opposite sides of the world had once shared the same home. Then, over hundreds of millions of years, Pangaea had split apart, and its jigsaw pieces had drifted to their present locations. Wegener called his theory continental drift. Wegener wasn't the first scientist to speculate that the Earth had once been dominated by a supercontinent, but he was the first to pull together all the evidence and make a strong case for it. Unfortunately, his peers weren't very receptive. There was no mechanism to explain how the continents might plow through the oceans. Continental drift was just too incredible to believe. As a result, his discovery was largely ignored.
Großvater, das mit sie.